Hello, everyone. Thank you for arranging the time slot, and thank you for giving us the time for this presentation. And we'd like to quickly introduce our recent activities to solve this problem that we described in this title. How can we replicate the legacy telecom infrastructure for cloud native? And let me introduce briefly ourselves. We are the biggest telecommunication company in Japan, and we are mainly focusing on using OSSs to solve this kind of problem. And today, what we want to talk today is already described here, and we want to explain our solution that solve this problem. And the very solution for us is making an adapter between the cloud-native projects and telecommunication infrastructures, like Mono, as you may know. And we are working on making that adapter called Tacker in OpenStack. So let me introduce it briefly. So Yasfumi-san, please.
Hi, my name is Yasfumi Ogawa. So I'd like to introduce our background first. So we have several challenges for migrating legacy telecom infrastructure on mixed environment on VM and cloud-native architecture. The below diagram shows the simple use case. So there are containers or VMs around there, and it's managed from OpenStack or Kubernetes as a virtualization infra manager, and it's also controlled from VNFM feature, which is for Virtual Network Function Manager. And this is just a typical challenge for us. For example, how to shift VMs where legacy applications just crammed into containers, or how to introduce a web structured management plan for both VNFM and CNF or so. And definitely, generic VNFM is the key feature. So for realizing such requirements, we have contributed OpenStack Tacker, which is one of the major projects in OpenStack, and its own features for controlling VNFs. And so orchestrating virtual telecom infrastructure is, for example, managing physical virtual machines and containers, or virtualized network and applications ranging from core to VLAN. So we have several use cases trying to adapt Tacker for them, and this is one of them, is VLAN on Kubernetes cluster with Tacker. So there are many components managed from Tacker. Is VDU or VCU. VDU is for virtualized distributed unit, and VCU is virtualized control unit. So Tacker manages all of these features as a centric control plane, and the definition of such a managed platform is given as packages called as VNF package via auto interface. It includes, for example, Helm chart or manifest or management driver of Tacker. And also, Tacker team has contributed to ORAN to handle lifecycle management, VDU and VCU. And ORAN is an alliance joining several telecom operators or vendors around the world to realize such a VNF world. And yeah, this slide is just showing one of our challenges, recent challenges in ORAN community is managing the Starlink X from Tucker. Yeah. Thank you.
Okay, thank you, Yasfumi-san. We're going to show a quick demo to describe how Tucker control the old Kubernetes resources. As Yasfumi-san said, there are many cloud-native projects, and we can use that directly, but there is no common interface to use that. So we want to make adapter to abstract those different cloud-native projects. That is Tucker, and we'll show the Tucker make those old components with HNFV standard compliant interface. Okay. Okay, this is the initial state. There are no clusters, and the first Tucker make a Kubernetes cluster on edge site. So this demo shows the Tucker make two-site edge and cloud, and now Tucker making a edge site Kubernetes cluster with cluster API. And the cluster is created, and the authorization configuration is sent to client side. And Tucker has a custom driver to achieve this kind of brief provisioning, like sending a kube config or something like that. And now Tucker scale out the edge site cluster with cluster API. So now the worker nodes is scaled out from 1 to 2. Then Tucker, now we show the Tucker upgrade the Kubernetes version on the cloud site. And the version is upgraded. So there are two clusters already set up, and we deploy the application on that cluster. And we use a machine learning application called Seldon as an example here. And we can see the edge can access to the cloud application. So Tucker control all of those things with the common interface. And then terminate all things. And like I said, we can do this with our Kubernetes projects like a cluster API, Kubernetes itself, and Helm, but there's no common interface which is suitable for the telecommunication company. So we make a Tucker as an adapter, like I said, over and over again. So that's all for for us. Thank you very much.